Hello guys, welcome back to the Dismiss channel. In my last video, I have shown you how to send the Kubernetes logs into the Loki, and from Loki how to create dashboards in Grafana. Here I want to show you how to create traces and spans in applications and send them to the open-telemetry, and how open-telemetry collects the traces, and then we can export them to the Tempo backend, and using Grafana we can visualize them. So the first steps that I have to do here is, first I will instrument a Python application. It's a Flux application, and I will instrument that application. The second step is the Dockerization of the application. We will create a Docker file, and then we will create the Docker image and push the Docker image into the public repository, Docker public repository. Then after that, I will test it and deploy it in the Kubernetes cluster. Here is the application. I already have instrumented. So these are the lines of codes that we have to include into the application. First, we'll have to create a tracer. If you go to the official website of OpenTelemetry Python SDK, here we can find out this example application. So you can see like it is importing the trace from OpenTelemetry. Then after that it is importing resources, then trace provider and batch span processor. First it will create a resource, and then after that it will set tracer provider for tracer provider, then resource is equal to resource that we have created. Then after that we will have to create a tracer, and then OTLP exporter, that is the span exporter. The endpoint will be, whenever we deploy OTLP, that there will be service, that service will have to mention. So this application will send those traces into this OpenTelemetry backend. Insecure true, currently we are not using any SSL or any certificate. For that we are using insecure true. And then span processor, that is batch span processor, that processor we are using. And traces, get traces provider, then span processor. Okay, this thing also required. And then we are instrumenting into the application like this. Tracer, we are calling the tracer, and then start is current span 2, and then printing hello world. So the same code I am copying from here, and then I have included here in this Flask application. So this Flask application is using the random module, and it is like displaying digit whenever we are calling the application endpoint. It is displaying the digit from 1 to 6. So all are similar to that, only this endpoint that I am sending to the open-telemetry-collector, because the open-telemetry-collector is running here. Suppose kubectl get service, you see the open-telemetry-collector, that service endpoint is my-opentelemetry-collector, and we are using the 4317, this port number. This is the port number that I am using. This is the endpoint that we have to use, so that this application can send the trace to OTLP exporter, and the endpoint of the exporter is this one. I am just giving the overview of the instrumentation. So if you want to learn more about the instrumentation of the application, you can go to the official website of the OpenTelemetry, and you can get some insight about this, how to instrument the OpenTelemetry. There is another one of OpenTelemetry official website. There is also another one for how to instrument a Python application, which is showing here. So the basic applications that I have taken is from here only. This is the roll dice application that they are using. This is the application. This application is sending the traces into the console, but we need to send the traces into the open-telemetry so that open-telemetry can send them to the Tempo, and then Tempo, from the Tempo we can get that into the Grafana and create a dashboard, or we can analyze the Tempo traces. What I will do, I will deploy my application into the Kubernetes cluster. So I already have running a Kubernetes cluster that is in Docker desktop. This single node cluster. For demo purpose, I am using this Docker desktop, and then after that, what I will do, creating a Docker file. So this is a sample Docker file that we are using a Python 3.9 slim base image, and after that, going to inside the working directory /app. After that, I'm copying that application into the /app directory, and then installing the Flask and open-telemetry instrumentation Flask, and then after that open-telemetry SDK and open-telemetry exporter OTLP. So these things need to be installed there. So these are the dependencies that we need to install there into the container. After that, I am creating a environment variable and exposing the application 5000. Then it is running a cmd command, that is python app.py. Okay, so this is the Docker file. I will use this Docker file to create the Docker image. Sudo docker build -t, then my repository name and an application tag. This is the tag name. Now enter. Insert. Give the password. Okay, it is now creating the Docker image. Okay, you can see the Docker image is created. So, Docker images. This is the image. What I will do, I will push that image to the Docker public repository. If you go to my public repository Docker Hub, you can see there is no applications after 3.1.1. Okay, the last release was 3.1.1, so I am releasing now 3.1.2. You can see 3.1.2. Just enter. Okay, the image is pushed to the Docker Hub, and can verify here. Just refresh it. We can see the image is pushed to the Docker Hub repository 3.1.2. Last push was less than a minute ago. Now what I will do, I will go to the Kubernetes cluster and deploy this application into the cluster. So I already have running some boards into the Kubernetes cluster. Sorry, HTTL git board. In my last video, I already have shown how to deploy Grafana, how to get the secret of Grafana to log into the Grafana, and then I already have shown like how to deploy open-telemetry-collector for Loki log. So if you want to refer to my video, you can go to that video, get some idea about the deployment of open-telemetry-collector. Here, what I have done is in the open-telemetry-collector, the values.yaml. So I am deploying the open-telemetry-collector as a deployment. Okay. And then after that, I have sensed the OTLP endpoint. This is the tempo distributor endpoint that I have received from this. This is the tempo distributor endpoint that we have to send the address to this endpoint, and I'm using gRPC here. We are not using HTTP endpoint. Okay. After that, in the pipelines, what I have done, I am just using OTLP. Okay. Okay, that's it. And then what I will do, I will redeploy the open-telemetry to helm list. So these are the releases I have deployed. I will delete this open-telemetry. Helm delete my open-telemetry-collector. Okay. Now I will use this command. I'll paste this command in my description. So this is the helm install my open-telemetry-collector. This is the start name and the values.yaml file that I am using, this values.yaml. So I am referring that in this path. Okay, just deploy. As you can see, open-telemetry is deployed. Now if we see the boards, you can see container is creating. I will delete helm, delete role, and also tempo. Tempo ports are terminating. So I will have only two deployments now. One is Grafana, another one is the my-opentelemetry-collector. You can see. Now I will deploy tempo. So where is my values file? So the values file is here in this directory, Loki distributed. Sorry, not Loki distributed. This is the directory where I'm having this tempo distributed chart, and I have this values.yml, and here if we see, I have modified this OTLP. So if we go to the traces in the values.yml, we have to enable this HTTP enable true, then gRPC enable true. Then only OTLP exporter can send the traces to this tempo backend. Okay, now let's deploy tempo. So I will get this path and paste it here. Then last we have to give values.yml. So this is the command. I will copy this command and paste it here. Okay, Tempo distributor is deployed now. The next step is to deploy my application that is already there in our Docker Hub. So what I will do, I will create a cert. How to create a cert? Helm create my app. Okay, you can see my app. It should be here. This one, you can see the chart is creating. If we go inside my app, you can list out, yes, this is the chart, this is this template file, this is the values.yaml. So here in this location I have created that my app, this one. So this is the chart, this is the template, and this is the values.yaml. Let's open this values.yaml. What is the repository? So the repository name, so I will have to go to the Docker Hub and I will copy from the Docker Hub the repository that we have posted. So this is the Docker Hub repository name, the image name. I have to copy this one and paste it here. After that, update the tag latest. I will have to update the service port for port, that is 5000. Why 5000? Because we have exposed the 5000 port in the Docker file, and I will disable this liveness and readiness probe for now. Let's go to deploy my application. So this is the command, right? I will copy this command and then paste it. So my application is inside my app, role my app, then values file is this one. This is the path of the values file that I am using. So in the values file, I already have shown that I am not using any liveness and readiness pro here. I'm exposing 5000 port, and then the image name is this one. Let's go and deploy this. This URL just here. Okay, non-absolute URL should be in the form of repo name path to start. Not my app. Okay, so now I have to. Okay, you can see the application is deployed now. Let's get the pod. Okay, so my application is now creating. Tempo is already deployed, and Grafana is also already running. Now you can see that kubectl get pod, all containers are running. My application is also running. What I will do, I will just port forward this application and see if I can access it from the browser. Let's get the service. So this is the application service, and this opening the port 5000. Let's do that. kubectl port forward. This service name is my role my app 5000. Let's take 5002 and 5000. Okay, let's go to the browser and see. Localhost. I 5000 to download dice. Yeah, as you can see, I can able to access the application. So whenever I hit the endpoint, it will give some random values. Let's go to another command prompt and port forward the Grafana service. So Grafana service is running at port 80. Now kubectl port forward service name is Grafana, and port number, suppose I am taking 3000, port number is 80. Now go to the browser, use localhost, and port number is 3000. In the background, I have to change port 5002 to 5001 for my application, as my system got hanged. As you can see, I can able to access Grafana dashboard from the browser, and my application is also running, and it is giving me the random values. Now what I will do, I will create a data source. Let's go to the connection and search for Tempo. Add a new data source. Here we have to give the URL for our backend. Let's go to another one command prompt and get the service. So this is the Tempo query front end. This is the service that we have to give as a URL in the Grafana. Let's get this URL. Go to here, construct the URL. The port number will be, you can see the port number is 3100, and save and test. Okay, data source is connected. Let's go to explore view, and if I want to see the traces, let's search. Okay, as you can see, there are 2 traces available. If we click the trace ID, then we can see their trace history. So what has happened in that particular request, we can see that here in this trace view. If we hit some more time, it will generate some more traces. Let's close it. And yeah, you can see some more traces been generated. So that is how we can instrument our application to get the traces using the open-telemetry SDK, and visualize them in Grafana using Tempo backend. That's it in this video. If you have any doubt, please feel free to comment in the video. Do like, subscribe, and share the video. I'll see you in the next video. Thank you.